Good afternoon, sir.
Good
Good
afternoon, sir.
afternoon.
Good
Good
afternoon, sir.
Good
afternoon.
afternoon, sir.
Good
Good
afternoon, sir.
afternoon. Good afternoon.
Good
Good
afternoon.
afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. Afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon. Okay.
Good afternoon, sir.
Good afternoon. Okay. Any doubts so far in whatever we have been doing? Any doubts anywhere?
No, sir.
Pakka? All okay?
Yes, sir.
All right.
Yes, sir.
Okay. Let me just open up my book. All right. So we were doing chapter number 3, that is flotation. And we had done example. So any doubts in this example so far? Any doubts in the example so far? No doubt?
No, sir.
All right. Okay. Let me come to exercise on flotation. So let me do example 7. Example 7 is a rectangular barge. Size is given 10 by 5 by 4. Is floating in seawater at a draft of 2 meters and is being taken out of the water by a crane. Find the load taken by the crane when the draft becomes 1.2 meters. So basically, you find out the displacement at 2 meter and you find out the displacement at 1.2 meters. That is how it is. So if you find out the displacement at 2 meters, then because it is salt water, so therefore displacement at 2 meters will be the volume into density. So volume at 2 meters into the density in which is floating. So volume will be the length into the breadth into the draft, into the density in which is floating, which is salt water. So that comes as equal to 102.5 tons. And similarly, the displacement for 1.2 meters draft will be 10 by 5 by 1.2. That will be equal to 61.5 tons. So the load on the crane will be the difference of the two. Which is equal to, that will be the load on the crane. Is that okay?
Yes, sir.
Okay.
सर एक और ये एक और सुन रहा
हाँ जी बोलिए.
एक और सर प्लीज.
When the draft is 2 meters of the rectangular barge, then it is 10 by 5 by 2, the volume, into the density in which she is floating. So the displacement when the barge is a 2 meter draft is 102.5 tons.
Yes, sir.
When the crane picks up the barge to a draft of 1.2, then the displacement of the barge becomes 61.5 tons.
Yes, sir.
So the load which the crane has taken is 102.5 minus 61.5. That is the load which has been taken by the crane. Because it's the crane which has reduced the draft to 1.2. The crane has picked it up.
Yes, sir.
That is what I was trying to say.
सर एक बार फिफ्थ का एक बार पिक्चर बना सकते हैं सर.
किसका?
ड्राइंग फिफ्थ का सर. ड्राइंग
Fifth.
यस सर. एक बार सर
Yeah.
ड्राइंग बनाना सर.
Fifth means example 5.
नहीं, एक्सरसाइज 3 का फिफ्थ क्वेश्चन नंबर.
Exercise 3 का फिफ्थ क्वेश्चन का डायग्राम चाहिए आपको.
यस 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 डायग्राम चाहिए.
A cylinder 2 meter in diameter and 10 meter long floats in fresh water.
Fifth, sir.
Fifth, sorry.
फिफ्थ, यस सर.
Okay, a barge of triangular cross section. Okay. You want a diagram of question number 5, correct?
यस सर. यस.
Okay. All right. I'll draw the diagram of question number 5. Question number 5. So it says there's a barge of triangular cross section 20 meter long. So length is 20 meters. And 12 meters wide. 12 meters wide. And 6 meter deep. It floats in seawater at a draft of 4 meters. Draft is 4 meters in seawater. We have to find its displacement. All right. So barge of triangular cross section. So ये रही हमारी barge. ये triangle है और ये है. So basically ये prism हो गया. ये हमारी barge है. ये 20 मीटर लंबी है. इसकी width 12 मीटर है. And इसकी डेप्थ 6 मीटर है. ये 6 मीटर है. ये 6 मीटर. And she is floating in draft of 4 meters. So ये इसका ये वाटर लाइन है. ये 4 मीटर की वाटर लाइन है 4 मीटर की ड्राफ्ट में. सो ये हो गया ये 4 मीटर्स. ये हमारा कील हो गया. दिस इज कील. सो लेट्स गिव सम नेम्स. P Q R S T U. ये हमारे नेम्स हो गए थोड़े से. सो बेसिकली मुझे SU चाहिए. सो सबसे पहले तो ट्रायंगल KPR is similar to triangle KSU. The बड़ा triangle is similar to the छोटा triangle. So therefore, the ratio of perpendicular to the base KQ perpendicular over base PR will be equal. So KT upon SU. Is this okay with everybody?
Yes, sir.
So therefore, KQ, which is 6, upon base, which is 12, is equal to KT, which is 4, divided by SU. 6 2s are. So SU is equal to 8 meters. यानी कि ये SU मेरा 8 मीटर है. All right. अब my underwater volume of KSU is equal to area KSU into length L. Area KSU is half into base into height into 4 into 8 into the length 20. 2 4s are. So कितना आता है ये? 320. So now can you tell me the displacement for KSU? That is the volume into density. कितना आता है?
So 328.
328. Anything? That's it?
Tons.
Sir,
So-
tons.
So many tons. Is this okay with everybody?
Yes, sir.
Okay. So like that, you can do all the remaining questions in the same manner. And do that. Okay. I'm moving on to the next chapter. And that next chapter is some basic definitions. So let us do some basic definitions. Okay. So these are some basic definitions which you are familiar with. Let me just revise them. So displacement is basically nothing but the mass of water displaced by a ship when she is floating freely. And the mass of the water which it displaces is equivalent to the mass of the vessel. So displacement is nothing but the mass in tons. Light displacement is the empty ship mass, that is no cargo, no fuel, no bunkers, etc. on board, just the displacement of the hull, so to speak, and the fittings. Load displacement is the total mass of the ship, which includes everything, which is include light displacement, it includes cargo, it includes the bunkers and fuels. Present displacement is the mass of the ship at present. Let me just share my screen with you so that let me know when you can see my screen.
Yes, sir.
Okay. So let me know any definition which you are not able to understand as I keep moving ahead. Load displacement is the total mass of the vessel when she is floating in salt water with a summer load line at the water surface. That is known as load displacement. Present displacement is the mass of the ship at present, which is the sum of light displacement and the everything which is on board at the present, which is cargo and the bunkers and the liquids. Dead weight is the dead weight of a ship is the total mass of cargo, fuel, fresh water that a vessel can carry when she is floating in salt water with her summer load line at the water surface. So also it is called as summer dead weight. So dead weight of the ship is the load displacement minus the light displacement will give the dead weight. And dead weight minus the bunkers will give you the amount of cargo that you can carry. So dead weight aboard is the total mass of cargo, fuel, ballast, fresh water on board at present. So present displacement minus light displacement will give you the dead weight aboard. Dead weight available is the load displacement minus the present displacement. That will give you the dead weight available. Water plane coefficient. Okay. Now we are coming on to the coefficients. So a ship is made up of various coefficients. So there are two coefficients in our syllabus in second maths. This is called as area coefficient, also called as water plane area coefficient, also called as coefficient of water plane. So it is a ratio of,
सर दिखाई नहीं दे रहा सर
दिखाई नहीं दे रहा है? Okay, sorry, just a sec. Let me unshare my screen. Okay, now can you see?
यस
Yes.
So CW is known as area coefficient, and it is given by a ratio of water plane area to a rectangle having maximum length and maximum breadth, Bmax. Water plane area upon the rectangle having the maximum length and maximum breadth gives you CW. Then there is one more coefficient which is called as, popularly we know it as block coefficient, CB, also called as coefficient of fineness of displacement. So इसमें जो CW में है उसमें थर्ड डायमेंशन एक ऐड हो गया, अंडर वाटर वॉल्यूम divided by L into Bmax into draft. ड्राफ्ट आ गया इसमें. So this gives us a block coefficient, CB. You will notice both CW and CB, CW and CB are going to be less than 1 always. They're going to be less than 1. That means the numerator will be less than the denominator in both the cases. Some popular CB values. Some popular CB values. CB for a container ship. Large container vessels generally have a CB approximately 0.575. CB for a bulk carrier are generally in the region of 0.75. CB for a tanker are generally in the region of 0.80. That is just as a broad guideline for you, so you should know. That means as the CB values keep decreasing, the speed will keep increasing. So container ships, that is how they are able to have a higher speed. Okay. Something called as reserve buoyancy. Reserve buoyancy is the volume of enclosed spaces above the waterline reserve buoyancy is the volume of enclosed spaces above the waterline. So therefore, reserve buoyancy is total volume minus underwater volume. And so therefore, reserve buoyancy is a percentage. That is above water volume divided by the total volume into 100. Why is reserve buoyancy called reserve buoyancy? Why is the name given? Can anybody in the class tell me why do we call it as reserve buoyancy? Anybody in the class? Why do we call it reserve buoyancy? Let me put it like this. Is reserve buoyancy providing me buoyancy at present? Okay, I'll ask another question. Tell me what is volume of enclosed spaces below the waterline? What is volume of enclosed spaces below the waterline called?
Underwater volume.
Underwater volume is correct, absolutely right. But in terms of buoyancy, what would we call that as?
सर रिजर्व buoyancy इसलिए कहेंगे कि जो मतलब उसमें उस एरिया में अभी तक buoyancy एक्ट नहीं कर रही है, इसलिए वो रिजर्व्ड है उस एरिया की buoyancy। अगर वो पानी के नीचे और सिंक होएगा तो वो वाले एरिया की buoyancy भी एक्ट करेगी फिर उसके बाद।
So, okay, I'll come to that. So what is the volume of enclosed spaces below the waterline called? So somebody said underwater volume, which is perfectly fine. It is also called as intact buoyancy because my hull is intact. So the buoyancy which the underwater volume is providing me is called as intact buoyancy. Now, this portion of the underwater portion, supposing this is my vessel, box shape I've just shown for easy. This is forward, this is after. And supposing this is one of my compartments, one of my tanks. And supposing, so this is intact. So this is my intact buoyancy. Now, supposing this gets holed and water fills in. The water fills in. So now this process of water filling, this is called as bilging. So if bilging happens, I have a hole.
What is these lines in which water is filled?
There's a hole here. This is a hole in my ship side. So the pani will come in
Yes.
through the hole. So the water has come in now. And these lines are, so pani has come in. Now I've got water inside the hole. This process is called as bilging. And if bilging happens, then my buoyancy, intact buoyancy, is no longer intact, but it becomes lost buoyancy. Buoyancy is lost. If buoyancy is lost, then I have some reserve buoyancy, which is on top. Volume of enclosed spaces above the waterline. So this volume, which is above the waterline, will give a portion of the buoyancy to the ship. And the vessel will now sink to a new draft. And the vessel will now have a new buoyancy. This will be a part of my underwater volume. This will be a part of my underwater volume. If the amount of the compartment which I have lost, if this lost buoyancy is X, then this portion which I will get from reserve buoyancy will also be X. So the purpose of reserve buoyancy is to give X when I have a bilging. That means I'm now in damaged stability. That is what is the purpose of reserve buoyancy, to be used in case of damaged stability. ठीक है? Is that okay? That is all you should know at this stage. So if I have a hole, then reserve buoyancy comes into play. Otherwise, it doesn't come into play. Okay. Something called as TPC. TPC is tons per centimeter immersion. It is the number of tons which will cause the ship to sink by 1 centimeter. The number of tons which will cause the ship to sink by 1 centimeter. So TPC of salt water is equal to 1.025 into water plane area upon 100. Therefore, TPC of dock water is equal to density of dock water into water plane area upon 100. This is known as TPC.
Sir, what is the meaning of sink by 1 centimeter?
What was the meaning of sink by 1 centimeter? Okay. So, if my vessel is floating at a draft of 4 meters and how many tons will it take for my draft to become to sink or to increase by 1 centimeter. That is 4.01. How much will it take?
Okay, sir.
That many tons. So supposing it is 20 tons. So supposing 20 tons, like the hinge ship of the TPC of hinge ship is approximately 21 tons. That means 21 tons will cause, if I load 21 tons, the draft of hinge ship will increase by 1 centimeter. So similarly, you try to remember what was your TPC of last ship.
What will be the water plane area?
Water plane area is the area of the water plane. That means the area at that draft is known as water plane area.
ये टीपीसी सर ये हर स्टेबिलिटी बुकलेट होता है ना हर जहाज में सर, उसमें दिया जाता है.
TPC is given in the hydrostatic particulars. Stability booklet में hydrostatic particulars में, like hinge ship के hydrostatic particulars में, you will locate it on page number 7. You will find it.
Yes.
That way. That is called as TPC. Okay. So let me come to the questions which are there. I am on example 2. The length and the breadth of the water plane of a ship are 100 by 12. 100 by 12. And the coefficient and fineness of the water plane, CW, is 0.7. Find the TPC in salt water and fresh water. You have to find the TPC in salt water and fresh water. So when coefficient of fineness is given, that means we are given the water plane area. CW is equal to water plane area upon length into breadth maximum. So water plane area is equal to 0.7 into 100 into 12. So the water plane area you can find out कितना आता है.
840 meters.
840 meters square. So now I want TPC salt water is equal to density salt water 1.025 into water plane area divided by 100. This will give me TPC salt water. How much is this?
8.61.
8.61.
6.1 sir. 8.6.
8.61
Yes.
tons per centimeter. Similarly, TPC fresh water will be density fresh water into water plane area upon 100. So that will give you TPC fresh water. So as you can see, TPC changes with density. It is directly proportional. If density changes, TPC changes. ठीक है? Is that okay? Example 4. Box-shaped vessel 120 by 14 by 12. Displacement W is 13776 tons. Find the reserve buoyancy in percentage in salt water. So displacement is underwater volume into density. So 13776 is equal to underwater volume into 1.025. So underwater volume is 13776 divided by 1.025. This will give me underwater volume. This is equal to 13. This is my underwater volume. My total volume is 120 into 14 into 12. So my total volume is so many cubes. So my above volume, above underwater volume, above water line, that is reserve buoyancy, is total volume minus underwater volume is how much? This is my reserve buoyancy, but I know it is in percentage. So reserve buoyancy in percentage will be this divided by the total volume. This will be my percentage reserve buoyancy. That is 33.333. That is my reserve buoyancy. Okay, is that okay? Any doubts so far? And let's come to the example 5. A ship is floating in fresh water at a draft of 6 meters. So draft is 6.8 meters. If the maximum freshwater draft is 7 meters, maximum freshwater draft is 7 meters. She's floating in fresh water, please remember that. The saltwater TPC is 40. TPC saltwater is 40. Find the dead weight available. Find the dead weight available. Okay. TPC saltwater I know. So therefore, can I calculate TPC freshwater? That is first thing that I need to know. So I find out the water plane area from TPC saltwater. 40 is equal to 1.025 into water plane area divided by 100. So water plane area will be equal to 40 into 100 divided by 1.025. This is my water plane area. That is 39.024 meters square. When I go to TPC freshwater, so TPC freshwater is density freshwater 1.00 multiplied by water plane area, which remains the same, divided by 100. So my TPC freshwater becomes 39.
सर ये वाटर प्लेन एरिया 3902.4 समथिंग आएगा ना?
Okay, okay. 3902.4. Yep. 3902.4. 3902.4. So TPC freshwater will be 39.024. इधर चला गया. That's right. So many tons per centimeter. This is TPC freshwater. Now, how much is the sinkage which is allowed? Sinkage which is allowed is 7 minus 6.8 is equal to 0.2 meters is equal to 20 centimeters. So therefore, I know my sinkage is equal to small w upon TPC. So therefore, small w, which is my cargo to load, is equal to sinkage 20 centimeter multiplied by TPC 39.024 tons per centimeter. Centimeter cancels. The cargo to load therefore is 780 0.48 so many tons. That means मैं इतना कार्गो और लोड कर सकता हूँ ताकि मैं ड्राफ्ट मेरा 0.2 मीटर्स हो जाए, 0.2 मीटर्स बढ़ जाए. दैट मीन्स मैं 780 टन और लोड कर सकता हूँ एट दिस टीपीसी. ठीक है. Please finish off exercise 3 and exercise 4. Please do the questions and solve them. इन क्वेश्चंस में अब डायग्राम कुछ ज़्यादा नहीं बनाना पड़ेगा. एक्सरसाइज 4 में, 3 में you had to make diagrams, 4 में there are no diagrams to make. The 4 is totally dependent on the formulas and the definitions of the terminology. So you have to just bear with just revise the definitions. किसी question में doubt होता है, please look back and see. You will find some reply there. You'll find some hint, something will be there. ठीक है? Is that okay? Is that fine?
Yes, sir.
Okay.
Yes, sir. Thank you, sir.
Okay. Chalo. All right. See you then. Bye.
Thank you, sir.
Bye. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.